Hi, everyone. Welcome to DevNet Create session on automating AWS security, leveraging SecureX. My name is Brendan Bouchard, and join with me today is my esteemed counterpart, Brian Sack, a security architect here at Cisco. Been doing the DevOps and programmability thing for the last 10 or so years now. Really working on transforming the way that we look at security, the way that we look at operations as a whole, and in the realm of leveraging SecureX to do that. So when we take a look at what we're going to do today is really break down, what is SecureX? How do we, automate against it in multiple different ways? So leveraging relay modules. Brian's going to walk us through the orchestration side of the house, taking it, from source code files to dashboard tiles. So really walking through the different API calls that are pulling this information in and making it easy to consume. So taking all of these things, pulling it in and making it as simple as possible. So when we take a look at the dashboard tiles themselves, we'll have an overall summary of our infrastructure, the flows that we have, our users, and the different kind of parameters that go around with that. Walking through the setup, it'll be push the deployment. It's a scripted deployment that will kick it off. And then from the configuration side, it's just a matter of adding the different elements. So, your API keys, your log group names, and then it just becomes a matter of consumption. So you'll have your dashboard, threat response, map everything out, and be able to take immediate action on that. So we've talked about it a little bit. Let's see it in action.
As we start this demo, the first thing that we're going to take a look at is the GitHub repo here. So this is available github.com, Cisco DevNet. It's going to be this TR05 AWS VPC logs. And here's all of the relay module files, as well as kind of the setup steps and process. So here's the threat response screen. We'll have something similar here by the end of this. But it'll walk you through the setup. So kind of prerequisites are going to be that the AWS CLI is installed, and then you have credentials with appropriate permissions to be able to push out Lambda functions. And then also, so here's the policy that you'll want to have applied for your API users. So this is not going to be for deploying the function, but this will be in order to leverage all of the function's capabilities. You can cut and paste those in there. And then the setup steps that we'll walk through from this standpoint. So all this stuff is wrapped up in here. And the next thing that we're going to do, so we'll jump over, and here's kind of the base level SecureX environment right now. So as it stands, I do not have the AWS module configured, nor is it listed as an available module at this point in time. So I have all the ones that I have deployed. AWS just doesn't happen to be one of them. So we're going to walk through everything from beginning to end as far as that goes. So what we'll jump right into then is the actual deployment process from here. So when you do, git clone for the repo, cd into that, I like using IDE just because you kind of walk through and set breakpoints and be able to manage things that way. But what you're going to look for is going to be this deploy relay Python file. And if we jump up here to the top, we can see that it takes some arguments. So in this case, it's going to take an operation. This is going to be the first argument that's going to be passed to it, and it's going to be either deploy, update, or remove. Then you're going to send it -r is going to be your AWS region, US East 1, the project name. Give some examples in here. Your SecureX region, your SecureX API client ID, and API client secret. And we'll walk through how to grab that here in just a second. And then these are going to be for the Lambda function. So the memory that's needed, and the default is 4096, and then the timeout, and the default here is going to be 90 seconds. So in order to get API credentials, from SecureX, if you jump over to administration and then API clients, you can click on there, and you can from here generate an API client with the appropriate permissions for your SecureX relay. So that will be used to deploy those configurations. And then from there, we will go ahead and get started. This deploy relay Python file is a wrapper to completely manage your AWS relay deployment. So it takes all of those arguments that we mentioned, and it will actually go through and create your encryption secret that will be shared between your Lambda function and the SecureX relay module to provide that encryption capability. It will push the relay module up to Lambda, capture the URL, and then create the configuration module within SecureX. So as we hit go here, we'll start to watch that run through. So you see here, created the secret key. It grabbed the token for SecureX, created the Zappa configuration file, so that's for that Lambda function. And now it is having Zappa go through and actually create the zip file and push that up to AWS. So this will take a minute or two. We'll just kind of watch it go through. The deployment is finished. We can see here that the app deploy, so it's the Lambda function being deployed to AWS, is complete, and then the integration module into SecureX, so that's the configuration element for SecureX, has been pushed. We will jump back over to SecureX and go ahead and configure it. So from here, we refresh the page just to grab the most recent modules, and then select Add New Integration Module. If we scroll down, we should see our brand new AWS module right here. So if we click New Module, there's going to be a handful of configuration elements that are going to be required. So your AWS API access key and secret key, the CloudWatch log group name, and the links to how to create those, and the permissions and the VPC flow logs are right here. So reference that, and that will give you what's needed to populate those. The region that your VPC is deployed in, the time zone, how many days back in increments of one you want to look back in the logs, the total number of flows, and then whether those are ingress flows or egress flows. So if you have a differentiated level that you want to prioritize, these fields down here are optional. So these are just optimizations to help speed up the relay. So if you find that you have a huge number of flow logs that you're tracking and you want to streamline how fast it's going and collecting those, this can help you do that. Then your AWS address space, and the module itself can do dynamic lookups, but it has to do them every time that it runs, and so it can add a little bit of delay. So from here, we'll go ahead and configure this. Have a module here, and then I'll just paste in the parameters that I have. Grab the time zone, say 5 days for now. For here, we'll call it 10,000 with 5,000 in either direction. And then the way that the subnets are is just comma delimited. So it's CIDR notation and then just comma delimited. So throw those in, hit save. It'll say AWS relay is configured, and it's going to run a health check, and it says your integration module has no issues. So we are good to go. Next thing we'll do is check out the dashboard tiles. So from here, if we hit customize, we can now see that we have our AWS dashboard tiles. So we'll create a dashboard, call it AWS. Let's just add all the tiles that we have there. Hit save, and now we can see we have our infrastructure summary showing our instances, the number of buckets we have. Our EC2 instance details gives us the name of the instance, and you can actually pivot to these instances directly. So you can see down here at the bottom of the screen, these are links directly to those instances, the size, the internal IPs, and then the state. Some metrics around your IAM login users, so the total number of users accounts. This is a lab account, so we have some older credentials, but ones that haven't had the credentials changed in over 180 days or haven't been accessed in over 180 days and are missing MFA. And then the same for API accounts. So the total number of accounts, and then of those accounts, which have API credentials that haven't been changed in over 180 days, and which API credentials haven't been accessed in over 180 days. And also our flow statistics. So ingress flows, egress flows, and whether they were allowed or blocked. And then you can specify the time period for those to see. And then as with anything in SecureX, you can resize, drag and drop, move things around to give it the look and feel that you'd like to have. So whether you're blending your different cloud infrastructures, whether you want to present that in addition to your firewalls, or however you want that presented, it's leveraging SecureX to be able to do that in the most applicable way possible. The next thing we're going to do is jump into the threat response capabilities. So from here, I am going to just do a search for, in this case, this is the public IP address of one of my EC2 instances. Found an observable, it's this IP. Click here and we'll say investigate in threat response. So it's going to pivot over here and it's going to start to run an investigation. And as we can see, we can start to see it maps out all of the IP addresses that we see that EC2 instance connecting to. And the arrows here delineate whether it was connected to or connected from. So the power of SecureX will add that context. So the AWS relay itself won't provide any context into what those addresses are. It just says, here's the connections that we know have occurred. But then whether it's AMP, whether it's Umbrella, whether it's VirusTotal or any of the other integrations, they'll provide that context to say, this is malicious. And we can see, was it unidirectional? Are we just getting connections from that? Is it talking back to and from that IP? And then which ones are benign? So we can see the bidirectional communication with these IPs. It's talking outbound to that one, and we have two IPs that are connecting to it. If we highlight this endpoint itself, we can see it captures the NAT address. So here's the internal address within the VPC. Here's the public IP. So if we click on the internal IP address, we'll get some options available. As we can see here, there's a pre-built option to isolate that EC2 instance. But if we have a internal process that we want to follow, or in this case, we have a custom orchestration workflow that we want to follow incident response around a compromised instance. And in this case, we are going to kick off our AWS incident response workflow that Brian's going to walk through right now. So you can see here. And with that, I will pass it off to Brian.
So thanks, Brennan. I appreciate it. I'm Brian Sack. I'm a security architect in our partner organization. And I'm going to be walking you through the capabilities of the SecureX orchestration tool, which allows us to continue on this theme of easy to simplify some complex or repetitive tasks and consolidate those into workflows, which allows us to automate responses to threats in our environment, whether it be on-prem or in public cloud in this case. So we're going to be looking at the SecureX orchestration tool, and we're going to build out a workflow that takes the Amazon AWS incident response guide and codifies it so that you can easily respond to threats in your environment. So with that, let's jump right over to a demo.
So as Brennan has just shown us, our operations teams can use SecureX threat response to detect security incidents in our public cloud infrastructure as well. We can also run automated response workflows from SecureX orchestration. In this instance, we're going to be running this particular workflow that I've developed for automated incident response within our EC2 environment. And what this will do, it will go and automate the incident response procedures that are outlined by the Amazon AWS Security Incident Response Guide. They have specific recommendations as to what to do when you detect or potential compromise within your EC2 instances. And this workflow will automate these procedures for you so that your incident response team doesn't miss steps or potentially compromise forensic information by not performing the steps properly. So if we go back to our workflow, we'll run the workflow manually. And as you saw, you can also run the workflow directly from threat response, and it will run these same procedures on the host that you indicate. If we go to the top here, we can see what the workflow is doing. It will collect information from that potentially compromised host that we'll be able to use later on in this workflow. The first procedure or activity that's going to do is going to enable termination protection to prevent somebody from accidentally terminating the compromised host, which will compromise our forensic information. It will move it to an isolation security group. So this will prevent an attacker from exfiltrating data from that particular host. And it'll also prevent new connections in from the internet to that host, but it will allow our incident response teams access to that to provide or to perform these forensic activities and to do additional investigation. If the host is part of an auto-scaling group or if it's part of an elastic load balancer, the workflow will disconnect it from both of those to ensure that no new connections are established from the outside. And lastly, it will create forensic snapshots of all of the connected EBSs or elastic block storage devices, and then tag the instance with the details about the investigation. So if we go to our EC2 dashboard and look at the instances that are running, this is part of our web tier. The particular host that we were experiencing issues with is this first one. If I jump in here and go to security, we can see that the workflow has moved this to an isolated security group and has tagged it appropriately that it is isolated, and it has associated a ServiceNow incident with that particular incursion. If you go to snapshots, you can see that it has created an incident response snapshot of that elastic block device. And that will allow our forensic teams to go and perform additional forensic activities on that without the potential of compromising that data. Returning to the SecureX orchestration tool, this particular workflow can be imported from GitHub. So you can take the incident response workflow, import it, and start using it in your own environment. We've published it out here under the Cisco DevNet GitHub, and you just import the JSON into SecureX orchestration, modify a couple of the variables based on your AWS environment, and then you're off to the races.
So the two demos that you just saw allowed you to get better visibility into your AWS environment using the power of SecureX. The ability to add a relay module that gains visibility and dashboard tiles, and the ability to import a workflow that allows you to automate a response within your public cloud environment. For additional capabilities and additional resources, go out to developer.cisco.com/security and find these SecureX modules and additional response workflows that are available out there. And in addition, you can browse the two projects that Brennan and I presented today out on GitHub to pull them into your SecureX and to begin to automate and respond to threats in your public cloud environment as well. Thank you for your time and have a great DevNet Create.